When I was a kid, one of my favorite foods was ice cream. There was a cheerful ice cream shop called Gada Ice Cream Parlor where my family and I used to visit regularly. The owner, Jethalal, was always happy to serve his customers. In the beginning, the parlor offered only vanilla flavor. Jethalal managed everything perfectly, preparing the ice cream and serving also. Business was going very well and everything was simple. However, as the business grew, customers started asking for more flavors. He was happy, but at the same time, worried also. I am now worried. How will I manage everything in this shop? The shop is too small. What should I do now? What could be the possible solution in this case? Can you guess? If not, then don't worry. In this video, we will explore the problem this scenario creates and the solutions to overcome this. Hello, friends. Welcome back to our Mastering Design Patterns series. Today is lesson 4, and we are diving into a widely used pattern, the simple factory pattern. We will cover what it is, why it is helpful, and how to implement it in the code. This pattern will be the foundation for understanding more advanced patterns like the factory method and abstract factory in the upcoming lessons. So, though the video is a bit long, please stick around until the end. Without further ado, let's get started. Returning to our scenario, imagine Jethalal's customers started asking for more flavors. He described his problem with his best friend Tarak Mehta, who would solve his problem instantly. Okay, I understood the problem. What are you thinking now? How would you solve this problem? I am thinking to purchase one chocolate ice cream machine and adjust in my shop only. There is still some space left here. Okay for now, but what if the customers start asking for mango flavor? Then how will you manage in this small space? Yes, I didn't think of that. Then what should I do? I am very confused now. Don't worry, bro. I have a solution. You should rent out a factory and move all the machines there. So the ice cream creation process will be handled there. And here you just need to serve. So in future also, if you add new flavors, it would handle easily in that factory. Wow! As always, you are a lifesaver for me. So this is how Mehta Saab solved Jethalal's problem. In programming, the simple factory pattern works similarly. Instead of manually handling the creation of objects in different cases, we can centralize that process. So what exactly is the simple factory pattern? The simple factory pattern is a creational design pattern that centralizes object creation in factory. You simply request the factory to create the objects for you. In Jethalal's ice cream shop example, instead of managing creation and serving both the process in one ice cream parlor, the factory produces the ice cream and he only serves them. The same logic applies in code. Centralizing object creation keeps your program clean and maintainable. Now that we have understood the concept, let's see how we can implement the simple factory pattern in 3 simple steps. Number 1, create an ice cream factory class that will handle the creation process. Number 2, add a method to create the ice cream based on the flavor requested. And number 3, use a factory in your main code to serve ice cream to customers. Let's look at code to understand the problem and the solution.
Okay, so now let's understand the problem that Jethalal was facing and how Tarak Mehta's solution helped him at code level. So for that, we will understand 5 main points here. First, we will try to add only vanilla ice cream and try to use the new keyword to create the vanilla ice cream. So let's go to the code. I have created a new console application. In that, now, as per our requirement, I will try to add classes. So our requirement is first, Jethalal will have only one type of ice cream, which is vanilla ice cream. So I will create a class for vanilla ice cream. Now, this class will just serve vanilla ice cream. So for that, I will create a serve vanilla ice cream method, and this method for now will just serve a vanilla ice cream. Consider this as our shop now. To use this class, what we have to do? We have to create instance of this class. So for creating instance, we will use the new keyword. So vanilla ice cream equal to new vanilla ice cream, and here if I call the serve method, then vanilla ice cream will be served. So let me just run this. Okay, so now vanilla ice cream is being served. Everything is going great. But now, what is the next step? We need to add mango and chocolate ice cream as well. So for now, we won't use any pattern or polymorphism, and we will use it in a general way. So let's see what happens. So for now, I am creating two more classes. I am just renaming them. Mango and chocolate. Okay, so I have created two more classes, and I will just change here also to chocolate, and right now we are serving a chocolate ice cream also. Okay, and here we are serving mango ice cream also. So I will write here mango and okay. So now we have three ice creams. Now in the program class, we have to create two more ice cream objects and serve them. For that, I will again write mango ice cream equal to new mango ice cream, and then mango ice cream dot serve mango. Then the one another was chocolate ice cream equal to new chocolate ice cream, and chocolate ice cream dot serve chocolate ice cream. And if I run this code, then I will have three types of ice cream, right? So this is simple. If a person comes and asks for ice creams, you will give three ice creams. But wait, in general, it won't happen, right? A person will come and ask for only one type of ice cream. So how will we handle this? For now, we have to ask the person which kind of ice cream you want. So we will change this code somewhat. So for now, I will ask the person what he wants. For that, I will first display him on the screen. These are the ice creams that we are having. We are offering vanilla, mango, and chocolate ice creams, right? Which one you want? So whatever he gives, we will store it in a variable. So I will store it in a string variable, type equal to console.readline. And based on this type, now I will load the ice cream object. So based on this type, now if vanilla is there, then I will load vanilla ice cream. If chocolate is there, then I will load chocolate ice cream. And if mango is there, So here mango is there. So I will load mango ice cream. And here I will load chocolate ice cream. And if someone enters something else, then I will send a message, no such ice cream available right now. Now, if I will run this program and see what is coming. So here it is showing we are offering vanilla, mango and chocolate ice cream. Which one you want? Suppose I select vanilla. Then I will get vanilla ice cream. Suppose I want mango. Then I will type mango. And I will get the mango ice cream. So our problem is solved. But the code now is very clumsy. And here, if you will notice, I have written here vanilla ice cream. Here again for chocolate I have written serve chocolate ice cream. And for mango I have written serve mango ice cream. Can you see a pattern in this ice cream? What is common in these classes? The method serve is common. So now the third point is with the use of interface and polymorphism, we will see how this code is optimized. Right now, you can see the code and it seems to be very cluttered. So first, let's try to optimize this with the help of interface and polymorphism. So I will create one interface with the name ice cream. Okay, and this interface will just have one method, serve ice cream, or for now I will give serve. Okay, and all these classes now need to inherit from this ice cream interface because all of them are serving only. So for now I will force all of them to use this interface. So each of them will give a warning now that you have to implement serve method. So for all of them, now I will implement first ice cream. Okay. So if you don't implement, it will start throwing compile time error. See. So you have to implement. So right now we have this method. We will remove that method, serve mango ice cream and individual method names and try to make it more uniform. So we converted this, and now we will convert chocolate ice cream also. We will implement ice cream here also. Okay, and here I will remove this. Now you can see that the classes which implemented the interface are having common nomenclature. So this is one of the main advantage of using interface, that it forces you to use that name only. So with this, our classes method names are consistent. Now we have to use polymorphism to optimize this code. Okay. Now we will get the error. Obviously, if you will write serve, then there is no issue. But now we have to use the concept of parent-child and optimize this code. This is the parent and these all are its child. So in polymorphism, if you remember, a base class reference variable can point to derived class object. So in our case, these all are now derived classes of ice cream. So first, what we can do is we can have one ice cream variable, and for now we will initialize it to null. Now, instead of using here directly individual variables, what we will do, we will use that variable only. See, now our code is becoming much more cleaner. Why this happened? Because base class reference variable can point to derived class object. So what is the derived class? Here, these all are derived class of ice cream. That's why we are able to easily point to those objects. Okay. Now, here also, we are again and again calling the same serve method. So, we can remove this and put it at the end also. So, for now, I will comment it out. And here, I will just simply check if ice cream is not null, then call ice cream dot serve. The output will be exactly same, but can you see the code which has been reduced? Let me remove this also, so you will understand that how optimized our code has become now with the simple use of polymorphism. Let's run. So if I use mango now, I got the mango ice cream. So everything is great here. If we can compare this with our example, so Jethalal is now having 3 actual creation of ice cream in his one shop only. So you can assume this as a shop. Here we are doing 2 activities: creation of ice creams with the help of new keyword, and we are serving also. But we don't want to do this much activity. We just want to do one activity. We want to move this code outside. So now comes the 4th step, which is the use of simple factory. So to implement simple factory, the 3rd step should be complete. That we just saw now. Now what I have to do is, because the class is having 2 responsibility, I want to move this responsibility of object creation from this calling class and put it somewhere else. Where I will put? I will create a factory class and move this code of creating the objects to that factory class. Now the factory class will be responsible for giving me those objects. So let's see how to move them. So for now, I will copy all this, create one class. Let's name it ice cream factory. So here Mehta Sahab came into picture. He suggested to create a new factory, if you remember that example. So we have a new factory. For now, I will make it static, and this factory will return ice cream. Let's make it static, and let's give it a name, get ice cream. Okay, here I will pass the type, which type of ice cream I want. So here I will pass the type, and from here, that code which I have copied, I will paste here. Here there is one error. Not all code paths are returning. So we will return from here. Okay. Return ice cream. So what I have done? I have moved this code which was previously here. Now I can delete this from here. What I will do? I will delete all these things. And now this ice cream factory will be responsible for creating the objects. So here I will just call that factory. So I will call this factory ice cream factory dot get ice cream, and here I will pass the type. So now if I will run this program, the code is exactly similar, but now instead of creating all these things which we are creating, vanilla, mango or chocolate ice cream in our main class or in our ice cream shop, now we have moved that to a new factory. So our main class, in this case our shop, has become clean. Now we can accommodate more customers also, right? Because we have only one serve method. Now if I will run, you can see the output is exactly same. But our code has become much more cleaner. Now suppose if I want to add one more ice cream, I can easily add that and implement it, and here I don't have to change. Only here I have to change. So for creating simple factory, what you have to do? You have to create a class and then have a method which will return the ice cream from a particular method. So we have completed 4 points here. The last important point is use of dictionary. So instead of typing here if else if, this all becomes too much clumsy. So instead of doing this, what we can do is we can create a small dictionary collection, and that dictionary collection will have all this data. So I will show you how to do that. I will create one dictionary, private static. Let me give the name to dictionary as ice cream flavors. Ice cream flavors. I will give what will be the key? The key will be string, and what will be the return type? Here, the return type what we want is ice cream. I will create ice cream. Okay. And I will give it a name ice cream flavors equal to, for now I am initializing here only, but as we learned in our last session of singleton, we can easily move it and make it lazily load. So in the static method, I will add all the ice creams that I have in this dictionary. So the key will be vanilla, and what will be the type? New vanilla ice cream. Okay. Similarly, we will have mango and chocolate. So I will give here mango ice cream, and chocolate. So this is the chocolate ice cream. Now you will see the magic. All this code is removed. This code is also removed. In fact, this code is also removed. Now we will ask this dictionary to give us the object. So here what I will do? Ice cream flavors, and here I will pass the type. Now I need to do one more check here. If in case the flavor is not available, then I have to send a null. So if dictionary dot contains key, then return this. Okay. Else, or return null. So now can you see the code? How this much has been cleaned? The code has been cleaned. You can see, right? If you will see here, there is no change. The code which we were using previously, that is the same only. But with the help of dictionary, we have optimized this code. Now, as I said, that with the help of lazy keyword or lazy initialization, you can do this all things lazily. And there are frameworks also available. So generally, we use frameworks like Unity application block, or frameworks like those which will be helpful for creating these dictionaries for us. So we don't have to create manually. We will look that in our upcoming videos. But for now, you would have understood how with the help of simple factory pattern, Jethalal has solved his problem of managing all his objects of creating ice cream in one shop itself. Instead of that, we move everything to a centralized location, which is in our case, ice cream factory.
So this was the live code. Now let's look into the pros of simple factory pattern. Number 1, centralized object creation. It simplifies object creation by having a single place for instantiation. Number 2, easy maintenance. Changes to object creation logic are made in one place, so it is easy to maintain. Number 3, straightforward to implement. Great for small application. So now let's look into the use cases where we can use it. When creating a few related objects without significant complexity, this pattern can be used. For example, simple ice cream or pizza store or document creation tool where objects are limited. Let's look into the cons or disadvantages of simple factory. Number 1, limited flexibility. Adding new object types or modifying creation logic can require changes to the factory code. Number 2, violation of open-closed principle. It requires modification of the factory when the new products are added, which violates the open-closed principle. Number 3, not truly a design pattern. It's more of a coding convention rather than an official pattern. So when should we avoid them? You anticipate the need for frequent changes or extension to the product types. In that case, you should avoid this pattern. Now it's time for an exercise. Answer the following questions in the comment. Number 1. What is the main benefit of the simple factory pattern? A. To create complex object. B. To centralize object creation. And C. To manage multiple factories. Number 2. How does the simple factory pattern improve code management? A. By allowing direct object creation in the main code. B. By moving object creation outside the main code. And C. By creating multiple objects. And number 3. Which of the following is not a characteristic of the simple factory pattern? A. It centralizes the creation of objects. B. It allows dynamic object creation based on input. C. It is a type of creational design pattern. D. It guarantees that only one instance of a class is created. Pause the video, solve the answers, and message it in the comment. I will give a heart those who give the answers. I hope you would have given the answer. Let's quickly revise what we learned in this lesson. Number 1, we understood that the simple factory pattern is a creational design pattern. Number 2, it centralizes object creation to simplify code management. Number 3, it allows you to handle multiple object types easily and flexibly. And number 4, it lays the foundation for more advanced factory patterns. Remember, this is not the gang of 4 factory method pattern, but an important prerequisite for it. Please review this carefully to prepare for our next lesson. We will explore that in our next lesson on the factory method pattern. So make sure you revise this lesson multiple times as it is a foundational step for the next lesson. Thank you so much for watching. If you have any questions or suggestions, drop me in the comment. Don't forget to like, share and subscribe. We will meet in the next video. Until then, take care and goodbye.